The objective of this project was to be able to calculate where the ping pong ball would land, so we could get it into the cup. We needed to find the distance away that the ball would land from the table. We used the formula, distance equals horizontal velocity times time. The materials needed were the meter stick, to measure, the cardboard ramp, to use as a ramp, the ring stand, to hold up the cardboard ramp, the starting paper, to use so the ball would flow more easily, the iPad, to record, the cup, to catch the ball, the tissue, to make it easier to catch the ball, the ping pong ball, and the scissors, to cut the tape.
To find the horizontal velocity, we used the formula velocity equals distance divided by time. To find the time and distance, we dropped the ping pong ball on the cardboard ramp, as the cardboard ramp was at a 15, 30, or 45 degree angle. These different angles changed the speed, changing the amount of time it would take. We measured the time it took to get across 0.705 meters, which was the distance we chose to use. It took the ping pong ball an average of 0.76 seconds when the ramp was at a 15 degree angle. It took the ping pong ball an average of 0.6 seconds when the ramp was at a 30 degree angle, and it took the ping pong ball an average of 0.5 seconds when the ramp was at a 45 degree angle. Then we had the time being the 0.76 seconds, 0.6 seconds, and 0.5 seconds, depending on which angle, and distance, 0.705 meters, so it was easy to calculate the horizontal velocity. The horizontal velocity for a 15 degree angle was 0.9276315 meters per second. For 30 degree angle, 1.175 meters per second. And for a 45 degree angle, 1.41 meters per second. To find the time, we used the formula time equals the square root of 2 times delta y over the acceleration due to gravity. We knew that delta y, which in this case would be the height of the table, was 0.765, and the acceleration due to gravity is always 9.8 meters per second. When we plug in those numbers, we have to start by doing 2 times 0.765, which is the delta y, and that would equal 1.53. Now you would have to do 1.53 divided by 9.8, and then you'd get the square root of 0.156122245, and the square root of that is 0.395, and that would be your final answer. 0.395 seconds.
To find the distance, we use the equation horizontal velocity times time equals distance. For the 15 degree angle, the distance equals 0.9276315 meters per second times 0.395 seconds. Therefore, the distance equaled 0.3664144 meters. This is where the ball would drop for when the cardboard ramp is at a 15 degree angle. When the ramp is at a 30 degree angle, the distance equals 1.175 meters per second times 0.39 seconds. The distance equals 0.464125 meters. This is where the ball would drop for when the cardboard ramp is at a 30 degree angle. When the ramp is at a 45 degree angle, the distance equals 1.41 meters per second times 0.39 seconds. Therefore, the distance equals 0.55695 meters. This is where the ball would drop for when the cardboard ramp is at a 45 degree angle. Our initial calculations were off for almost all of these, but after a few adjustments, we were able to get it in the cup perfectly. Our overall objective was to see how far the ball would have to travel off the table to get into the cup.